Welcome back, students. In this video we're going to cover Station 7, geometric measurements from the 2026 boot camp. Geometric measurements are going to cover volume and surface area, I believe. Let me just double check. Make sure it is area, volume, and surface area. So, only off by one. All right, so we have notes over here on this left page, and at the bottom we have some formulas. So you can kind of see it's down here, and it's off the reference sheet. So we're just going to go with the reference sheet for just a moment. Let me see if I can zoom out far enough to we can see most of it. Underneath is your trigonometric ratios that we talked about for Station 1. But yeah, so this stuff that was in the little packet, it's your one side of your reference sheet. While I have it here, let's just flip it over the other side. We have our conversions if you need any of them. Something I want to point out as we near the test, and I'm trying to think of anything I can to help you guys. Just make sure when you're reading the problem, read all the words. And also pay attention, that the problem's talking about all the same measures. We've had examples where we had cows and we had to take the pounds of milk per acre, and then we had to turn acres, and actually acres is not here, but it gives you in the problem. We had to convert acres to square miles, and just keep all these things in mind. So they have some examples here if you guys need them, showing like the slant height. That's the 13. The actual height is 5, and it's down here. That sort of thing, and you guys can refer to it. For the purposes of this video, we're going to go, we have problems 1 through 4 on page 21 of the packet, and on page 22 we have problems 5 through 8. I can tell you number 3 and number 8 are the same question, so when I get to the end, I'm going to mention it again, but, I'm going to also give you the option to try to work it again. That's totally up to you guys. This is kind of how to be in college is the way I've been doing things. In college, students pay to go to school, and professors are paid to teach, and that's kind of how it is. And there's not going to be anybody there to shake you and push you. You have to do the right thing even when nobody's looking. And I hope we get better. Some of you guys, I've watched you grow this year, and I'm very proud of you. A lot of you guys that watch are not in my class, and I appreciate you guys. I hope to get to spend a little time with you before the end of the school year. You definitely got to come sign my yearbook when I get it. I'm going to try to get that tomorrow. But anyway, sorry, I was trying to find a better color for this. But anyway, so let's get started. I've already wasted 3.5 minutes. So my bad. All right, so we're going to find the volume of each three-dimensional shape. So over here, we're looking at a prism. Now this is a triangular prism. I'm going to just kind of do this, and then back here. So what I'm doing is I'm showing you the base of this guy, or the bases are triangles. That's the front and the back, and I'm hoping that makes it a little easier to see. Let's see. Because the base is the triangles on top. This is the top and the bottom. So this is your height. That's the main reason. All right, give me just a second. I apologize. So we're going to find the volume. It's going to be the base area times the height. I want to remind you guys that capital B, and these are on the reference sheet, but so capital B is base area, and capital V, that's volume. This little h is height. So I told you this is the top, this is the bottom, so this is the height. It's lowercase because it's a measurement. base area. So for a triangle, we're going to find it down here. I'd been starting to just put all the formulas together, but they're, I want to shout out to Miss Seiler. She taught this station and taught me a few things, and I want to just say I appreciate that. So, but we know the height's 8. We're going to put that up here. We're going to find the base area down here. And for a triangle, it is 1/2 of the base times height. So notice these are lowercase because it's, so your base is 5. So 1/2, 5. Now your height, let's see, double checking. Yeah, height here is 7. We don't have to find, you know, sometimes we have to use the triangle, and we're going to have to do that over here for slant height, but we're all good right here. So base area is going to be 1/2 of the base times height. So the 7 times 5, that's 35, and half of 35 is 17.5. So if you put this in your calculator, you know, 0.5, or just do 5 times 7 and then divide it by 2. Either way, you'll get 17.5. So we now just 17.5 times the height. That gives us 140, and that's cubic centimeters. Volume is always going to be cubes because it's measure times a measure times a measure. Here, centimeters times centimeters times centimeters would be centimeters cubed. Down here, this would be centimeters squared. That's the base. Give me just a second. Got a mosquito in here. And I know, well, again, most of my viewers, I think, are not in my class. I don't know about your classrooms, but in our classroom, when we see a bug, everybody just freaks out. And I was preparing for that, but I realize it's just me. So, number 2. They're telling us to use 3.14 for pi. Remember, I told you guys, if you've watched me at all, I always say we use this, except we use this for pi, except when it tells us otherwise. So we're going to do that. So this guy here goes all the way across. You know, our base for this cone is the circle. I'm just going to kind of color it in just to. I don't know if you can see much of that. Hang on, let me try one more time. I won't take up too much time. Okay, so the green portion would be the circle at the bottom. So the diameter is 10. The radius is half of the diameter, and half of 10 is 5. Okay, so volume for a cone from my reference sheet is 1/3 of the base area times the height. Now I will do what I've been doing here. So 1/3. So base area, if it's a circle, if you look that up, it's pi r squared. See it? B equals pi r squared. So I'm just replacing or substituting, and then we got the height. So we know the radius is 5. So let's see. We go 1/3 pi. So the 5 was our radius. 5 squared. 5 times 5 is 25. And then the height is 6. So let's just do this. We're going to clean this guy up. So we have 25 times 6. And we want 1/3 of that. So I'm going to divide it by 3. All right, so we have 50 pi left. Well, we're not going to use the pi button. We're going to go 50 times 3.14. And we're going to end up with 157. And they did that to keep us from having all these decimals, which we could have just said to the nearest whole, but that's fine. Just for giggles. Okay, so this is the answer. But just for giggles, okay, let's go 50 times pi instead of 50 times 3.14. I'm just going to, let's see. Do this. So it's 50 times 3.14. So that was there. But if we do this, all right, so 157.07, if we round it, it would have been the same. I think they wanted you to, I don't know. I don't know why they did that, but it's fine. It's fine. It's fine. So, number 3. So a couple of things. So the candle's in the shape of a pyramid. The volume of this candle is 27 cubic centimeters, and its height is 6 centimeters. They want the area of the base of our candle. So first thing we're going to do is type out, Lord. We're going to write out our formula for the base. For the volume. It's going to be 1/3 of the base area times the height. And they give us the volume. They tell us it's 27. We still have 1/3. We're going to be finding the base area because that's what it asked us to find. And we have the height is 6. All right, so let me clean this up. So 1/3 times 6 would be like 6/3, which is 2, right? In case you don't believe me, and it's fine. So 1 divided by 3 times 6 is 2. So now we have 2b, and then on this side, 2, or not 2b. Sorry, wrong class. But no, so this guy made 2. These made 2. We still got the base. We know the volume was 27. This is all we got left. So we're going to divide both sides by 2. And we're going to see that the base area is half of 27. Which, just because it's late, and I have like 3 more videos to do. Really, yeah, 3 more after this, but I'm probably only going to do 2 tonight. Actually, this plus 3 more makes 4. I'm probably going to get 3 total due tonight. And let's see, this was cubic centimeters. The base area is square centimeters. Because remember, area is length times width, or base times height, or whatever, and so it's cubic. Square. And then volume is 3 things, so it's cubic. All right, remember, so this is number 3. So if you want to try this on your own on the back, I'm just going to put, when we get to number 8, that see also number 3, and it's up to you guys. All right, so number 4. Hopefully you've been able to hear me. I've backed off from the microphone. All right, so we got 2 containers. They hold liquid. So if we're holding liquid, we're talking about volume. These containers, it's like, watch it ask for something else down here just to make me mad. So these containers are exactly the same shape. Now, remember, in order for 2 shapes to be similar, that's the first thing. They have to be the same shape. So the first container, it has a height of 20, and it can hold. So this is your volume. This is your old. We're going to go new over old here. So this is your old. Your second container, that's your new. So it has a height of 35, and they want to know how much liquid it can hold. So how much volume. All right. So when we're talking scale factor, that's how much, the dilation. For volume, it is your A over B, or over here, new over old. 1 second. Okay, sorry. Let me see. So yeah, new over old. So, but your A over B, new over old, when it's volume, it's got to be cubed. So let's go over here. So for the first thing we're going to do is find the scale factor, and then we're going to multiply. So it'll be volume 1 times it's A over B cubed is going to give us volume 2. And new over old is going to be, so your height for 1, that's going to be old, is 20. The height for the new is 35. Volume is 192, so it's going to be 192 times. We're going to figure out what the scale factor is. So you don't have to cube these numbers because they'll be gigantic. Now, of course, you're going to, in the calculator, you're just going to put this, and I know some of you guys love to put the fraction, and that's fine, but I would prefer you do, you'll divide it, because it's going to be a decimal, either point something or more than one. If it's more than one, it gets bigger. If it's less than one, it gets smaller. See here, our height was 20, now it's 35, so this is more than one, so it's going to be an enlargement. So let me just write this. So greater than 1 equals enlargement. Largement. This is why I teach math, because I'm not good with the words. Less than 1 is a reduction. Also means it gets smaller. And then if it equals 1, well, if you multiply yourself by 1, you would still be just you, right? So if it's 1, it's the same. And they will throw that in there to mess with you. But let's look at this. Can we reduce this? Reduce? Question mark? Well, yes. Use 5 as your greatest common factor. So 5 goes into 20 4 times. 5 goes into 35 7 times. So now let's cube these. So on the calculator, so I'm going to go 7, and then this button is telling it that the x means that you're going to tell it the exponent. So we hit 7 to the 3rd power, or cubed, and then equals. So 7 cubed is 343. Just going over here with it. And then 4 cubed. So 4, this button 3, because it's 4 to the 3rd power, and that's 64. So put it over here. 343 divided by 64. So new volume. So it's going to be, we'll do this first. So 343 divided by 64. See, it gives us 5.35. So because this is cubed, it's not 5 times bigger. It's just 5.35 times as much volume. So multiply it 1.92, and you get the new volume of 129. So V2 is 129. And you could always call it V old, V new, that sort of thing. But yeah, so we took the old volume that they gave us, 192. We found the scale factor after reducing and cubing it. So 343 divided by 64 times 192 gave us 1,092. And look at me not putting the measurement. So it's cubed. Alright, flip it over. Alright guys, I got a ton more to do and running out of time. Okay. Top of the next page, number 5. And these are a little better shaded. You can see this is the base. It's a circle, because that's a cone. They want to find the surface area. So on the reference sheet, surface area for this guy. And I am going to, so it's base, because there's only one base, plus. So to get this guy being a cone, it's pi times the radius times the slant height. So the slant height is over here. We have the radius. Radius is 15. We have the height. That's 8. But we don't have the slant height. What we do have is a right triangle. So this would be, L and L would be the same. This would be the same. So what you have is 8 and 15, and our slant height is our hypotenuse. So 8 squared plus 15 squared is going to give us our slant height squared. So 8 squared plus 15 squared equal. So length square is 289. We want square root. We hit the button here under tan. So our slant height is 17. So we have that now. So let's start plugging in numbers. So our L is 17. Oops, 17. Our radius is 15. 15. We got pi. And then the base area, so because it's a circle, it's pi radius. So radius is 15 squared. All right, so let's clean some of this up. I know that 15 squared is 225, so this is 225 pi. Plus, so this is 17 times 15, so that's 255 pi. And you do this a couple of ways. You could always multiply them out. I'm going to go 255 plus 225, and that's going to give me 480 pi. And now our surface area is 480 times pi. Pi is 3.141592654 and a lot of other numbers. We got to hit equals. 1507.9, we're going to round that to 1508. Those were inches squared because it is surface area, so still area. So all you're doing is covering this cone with either some paint or maybe some wrapping paper. All right. Number 6. So got another shape, surface area. This guy is it's a rectangular prism. So your rectangles in the front and the back. These rectangles are your faces. So our surface area, put this up here. It's going to equal 2 bases because we got one on the top, one on the bottom. We need to know the perimeter times the height. So the perimeter would be walking around it, and then the height would be this. So that covers the middle, base here, that's your 2 bases. So first things first, perimeter. This is a rectangle. I think I did that, but it's actually this way. Anyway, it's length plus width plus length plus width because it's walking around it. I walk from here to here to here to here. So 5.2 plus 10 plus 5.2 plus 10, that's 15.2 plus 15.2, which equals 30.4. So we got our perimeter. I'm just going to bend this paper. I'm just going to scoot it over. So the 30.4. The height. So this is your base. This is your base. Your height is right here. So because if it's on if it's on here and here, this is how tall it is. So 6 is the height. All right, now base area over here. So base area. So the perimeter was length plus width plus length plus width. Base is just length times width. So it's 10 times 5.2, which is 52. So we got 2 times 52. Well, we'll just do 2 times 52 since we got to move all this down. 2 times 52 is 104. 30.4 times 6 is 186.4. Sorry. And if we add those together, we get a surface area of 286.4 square centimeters. Sorry about that. It did not say as far as rounding, so we left it like that. All right, at the bottom, as I already told you, number 8. So this is the same as number 3. You good with that? Or if you want to practice it, please do. Over here, so a couple of things. The model of the roof is in the shape of a square pyramid. That means this is a square. So this is 5, this is 5, over here is 5, and over back here is 5. They want to know the surface area. So surface area for a pyramid is 1/2 of the perimeter times the slant height plus the base. One base because it's got the bottom. So base area, because it's a square, it is side times side, which is also side squared. In this case, it's 5 squared, which is 25. So base area over here, 25. Plus, all right, slant height. They're asking you for that. And they give us the surface area. So you can do, perimeter. For a square, because that's all sides are the same. It's 4 times the side. In this case, it's 4 times 5, which is 20. All right, so you got 20. We're looking for the slant height. You go 1/2. All right, so 1/2 of 20. Let me just separate these two guys over here. We'll go in red. So 1/2 of 20 is 10. L plus 25. And they gave us the surface area was 64. So I got to put that here. So we got into the other space there. All right, so we're going to subtract 25 from both sides. So these cancel. We got 10L and then 64 times 25. Sorry, I was in the thing too much. 64 minus 25. So 40. So we had the 64. That's the slant height that they gave us right here. And so we'd worked out all this. We took the 25 we had here. That was the base. We subtract it from both sides. 64 minus 25 is 40. Wait a minute. That's terrible math. 64 minus 25. Yeah, it's not 40. It's 39. Man, what did I do? So anyway, 39 equals 10L. Both sides by 10. So our slant height is going to be 3.9, and this is centimeters. So we just had to work it backwards. This is number 3. So this will conclude Station 7. I'm trying to get Station 3 and 4 to you guys tonight, and then let it be something you watch right before you go to bed the night before the test. Wish everybody good luck in case I forget to say so. Again, hope to see you guys between now and the end of the year. Don't get me in trouble, so come after school. Speaking of which, and you guys watch tonight, I hope you get to this point. I will be tutoring tomorrow. I can only stay till 3, so you have to have a ride. But I do have at least 2 students staying. Not and one's from my class and one's not, so anybody's welcome. 2 to 3 tomorrow in my classroom. Send me a message, or you guys know where I'm at. I'm across from Miss B's room. So, but if you do need me, reach out in focus. Until next time, have a good night. And I hope to see you in the next video.